Hello viewers, welcome back to another teardown. This one might be, to be honest, my gut feeling says there's not much in this, but we'll take the lid off and see what we can find. This is an unusual bit of thing that I saw on eBay and just picked up for 15 quid. I thought, yeah, it's worth a shot. So this is an Eppendorf Transjector, which is... Why do all this scientific stuff have such impressive names? Yeah, Transjector 5246. Done a little bit of research, and from what I can tell, this is part of a large setup. When you might have seen them on various science and news programs where they are manipulating an individual cell and they inject stuff into it. This is the sort of thing that this is used for. The larger setup would be like a big microscope, micro pipettes, which are glass, extremely fine glass pipettes that are on actuators, and you have little joysticks to actually manipulate this stuff down to extremely small measurements. And I think that this bit of it is the thing that actually does the injection process. So when you need to inject something into a cell. I don't know what, because I'm no biologist by any means. So yeah, I'm not quite sure what's going to be in this. There's some ports on the front. We've got I1 and I2 and T1 and T2. These are plugged off, so I suspect they're not in, whatever it is, it's not installed on this model. It's quite a heavy unit. Which is partially why I think it might just be a load of nothing. But on the back we've got a DB9 connector, we've got an old DIN connector, and an unusual one with a threaded lock on it as well. No idea what these are used for. Power input on the back, usual stuff. Now if we come back round to the front, these ports look to me like they are for air or gas. They don't look liquid to me. I'm kind of wondering whether this might be some kind of air actuated system, possibly, to do the actual injection thing. Without seeing more of the parts, it's hard to know. Tell you what though, it's a very nice case. It's well built. It's all metal. Probably make quite a nice project box, to be honest, but right, yeah, we don't have a lot in here, but there are some interesting things. We've got this massive, great big aluminium block assembly, which looks like it's got some kind of piston arrangement on it. We've got a large motor, gearbox, and a big cam wheel. The block here has a ton, well not a ton, but there's 1, 2, 3, 4, 5 will look like sensors on it. We also have some 4-pin devices there. I'm not sure what they are, whether they're sensors or if they're using that as a heatsink. That's possible. They're just plugged in on a PCB down at the bottom there. It's all on a rubber mount. So I guess this would have made a bit of noise when it was running. Let's take that off. I've got a protective cover there, covering up the mains filter and the voltage selection taps for the transformer. Transformer runs down onto a connector to the PCB. Right, let's see if we can get the front off. Yeah, I think if I just undo these 2 screws here, this front panel should come off. Good grief, yeah, look at that. It's a massive, great big die-cast bit of aluminium there. So we've got two pipes that run over to those 2 front ports. So it looks like these disconnect pretty easily. There's just a little thumb screw on there. Right, I think what I'll do next is pull out this assembly, and then we're going to have a quick look at the circuit board. So these all connect through onto the board at the bottom. Cable for the motor. These are all these black sensors here. So that's a better look of the motor. That looks chunky motor, that one. It is rated at 12 volt, 2 amps. So that works out to 24 watts on the motor. Yeah, it's a big motor, that. So these sensors on the sides are all the same. There are MZH304K. They're all identical, it seems. Yep, they are all the same. It's made by Festo. So let's just see what those are. Unfortunately, the Festo website isn't working properly, so I can't get the data sheet, but it says it's a single solenoid valve. Spring return with manual override, nominal size 0.4 millimeters, molded in cable, plug-in connector with LED indicator. No, I can't find anything to actually download, but they are a solenoid valve. So I don't know what potentially might be happening is obviously, if you've got to think about the scales that this thing has to operate at, you're not going to need a lot of air. So this kind of big large pump thing might just be to create a large reservoir of pressure, and then these valves just switch a small amount of that into whatever it is, the pipettes, I don't know. But yeah, these valves seem to be quite expensive things. Currently on eBay for about $70, so yeah, they're not cheap. Right, I might take that apart a bit further in just a moment. Let's have a look at the circuit board. Right, so if we have a quick look around the circuit board, obviously the transformer plugs in down at the back here. Pull that out. So we've got power supply stuff around the back, large bulk capacitor, that's 25 volts. We've got 2 regulators. We've got a 7812 and a 7912, so we've got plus and minus 12 volts there. Bridge rectifiers just in the back, another bulk cap there, and a 7805 on the back there to give us 5 volts. Not a huge amount going on around here. Anything on? Can't see anything underneath. We have a TMS 27C512. It's not an EEPROM, it's a PROM. There's no window on it, so I should be able to read that on my programmer actually, so I might dump the contents of that. Moving on a bit further over, we've got those connectors. That has got Amphenol written on it, so that's a nice expensive connector. 9-pin D connector there. I presume that's RS232 maybe. And that DIN connector. So I'm not sure what these are used for, but I'm sure there would have been hand and possibly foot controls and all sorts of things to actually operate all this. Then the main business is this device here, which is a Siemens 80C517A. Copyright Intel on it, and that is a 8-bit CMOS single chip microcontroller, up to 18 megahertz, but the clock, the oscillator there is actually 12 megahertz, so it's actually only running at 12. 32k of ROM, 256 bytes of RAM, and 2k of RAM as well. It's obviously a separate thing, and various microcontroller-y stuffs, counters, timers, 10-bit A to D converter with 12 multiplexed inputs. Can't see much else on there of interest. We've got a little buzzer there. Interesting connector there, possibly for expansion, or maybe this could have been plugged into another larger bit of kit. Oh, and there's a couple of linear LT1031, got two of those voltage references, so those are quite nice. I might extract those off the board before it goes to recycling. Right, let's bring up that pump thing, and we'll take that to bits. But you know what, before we do, let's try running it. So it runs on 12 volts. So let's try 6, 2 amps. Huh. Funky. Right, let's put that up to 12 volts now then. I've just got this plugged into my bench power supply. So yeah, that's at 12 volts. Yeah, I guess I can't really make it do much more than that, really. Yeah, I kind of wonder whether this might have just like run for like 1 revolution or something. Because I can't see this being the actual force that does the injection thing. I think it's through these solenoids here, which are actually really small, high precision things. I think this is really just to provide sort of bulk air pressure. It was a nice quiet motor though. Right, so I think what I'll do first is take the motor off. There's just an Allen key there. That should release that, and then I should be able to take the motor straight off. That'll make things a bit lighter. There we go. So that's the cam taken off. Nice bit of, looks like some kind of fiberglass reinforced plastic. Tell you what, the construction of this looks really nice. Yeah, there's been no expense spared at constructing this, is there? So that's the gearbox. Yeah, you can just see the gears in there. We've got simple, just a reduction gear set up in there. Right, let's just start disconnecting some of this stuff. Okay, I guess that was under pressure then. Well, that gave me a shock. Wow, yeah, that gave me a bit of a shock. Yeah, I guess they're not they're pressure sensors, and yeah, it looks like this is some kind of pump which builds up a pressure which can then be used as a reservoir to be switched by these things. I think that releasing all that pressure then was sort of answers that one, I think. God, didn't expect that at all. Right, so these sensors then, we've got a 136 PC100G2. And yes, it's a bridge pressure sensor. Spec is 0 to 5,170 millimeters of mercury, which is 0 to 100 psi. So yeah, that just pushes in there, and presumably there's just a one-way valve. Pretty simple affair there, with just a little bit of grease around it. Right. So yeah, this looks like it was just a reservoir. So that piston pumps into here. That's going to come through to this port here. That'll build up a reservoir in here. We've got a port there and there. So there's obviously more. Yeah, it's a bit hard to tell where that all goes, to be honest. We've got a blanking plate here, so there's obviously some ports being drilled. There's a plug there. We've got a vent there, so potentially that one might vent the reservoir out and dump it out to atmosphere. Got a couple of ports that run up there. Can't really see where they'd run to. Yeah, it's going to be hard to figure out this, to be honest. But I think we can sort of roughly figure out the operation. So the motor pumps up this reservoir, and then presumably these sequentially open and close to release part of that pressure into the output. Not quite sure why you have two, and then that actually activates the actual things that do the injection. So yeah, it's kind of interesting. Right, I think that pretty much concludes this one. It's not really too much more to see now. Yeah, it's just an example of some mechanical and electronic engineering. Not any real massive science stuff, but interesting nonetheless. So like all my other teardowns, I do like to pass on and give away some of the things that I take apart. So I think this is one of them. If you think you can make use of this or any of the other bits, please let me know, and I can normally post things out for literally just the cost of the post, and maybe it can you can turn it into some kind of project. I don't know. So anyway, thanks for watching. Hit all the like buttons and all that sort of stuff. Again, don't forget that bell icon. Comments are welcome in the comments section, and I will see you on the next video. Bye for now.